In this episode, I would like to show you the most simple form of a discharge tube, as well as how to fill it with some gas. After finding my millimeter thick tungsten wire, I cut off two pieces of it, both around 5 centimeters. At first, I prepare a small pile of potassium nitrate and a beaker of water. After getting my tungsten electrodes red hot, I dip them into potassium nitrate and then burn off the oxides in the flame. Afterwards, I dissolve any residual tungsten nitrates in the water. This procedure cleans the electrodes and exposes the shiny metal surface, which can easily bond to borosilicate glass. Next, I place a borosilicate tube into my drill, and after evenly softening the glass, I quickly press the electrodes inside of it and then give the glass some twist. Afterwards, I get two vacuum-tight tungsten electrodes. These are usually used in various electronic vacuum chambers, as well as in neon lights. Next, wearing a dust mask and having my exhaust running, I cut a circular hole into the main thicker body of my discharge tube. I then ensure to remove any stress from the glass by slightly melting it. Following, I heat up the gas exchange tube, and once both are hot, I join them together and let everything cool. Finally, I assemble the whole device by first adjusting the diameter of each electrode tube, and then I merge everything together. Last step is to dry the device of any internal moisture and create a narrow section. This will allow for extra resistance, so that the current can make a brighter glow. Once everything cooled, I wanted to do a vacuum test. I connected the tube to my vacuum pump and also got out my Tesla coil. As you may see, the pressure inside was low enough for the residual air and primarily nitrogen to be easily ionized. Next, I hooked up my 10 kilovolt neon power source, and I was quite satisfied with the result. From both ends, I also decided to add some epoxy to maximize the seals. Unfortunately, I don't have any pressurized gases to put inside the chamber, so instead, I wanted to try some carbon dioxide, for which I began to assemble my gas generator. Since vacuum tubes only work under really low pressure, I also make sure to seal everything with some petroleum jelly. So here I have my whole device assembled. Over here I have my gas generator. At the bottom I have sodium bicarbonate, and in the addition funnel I have 36% hydrochloric acid. When the two react, they will produce sodium chloride, water, and CO2. The CO2 will then go up the pressure equalizing tube and into my gas dehydrator, which has some concentrated sulfuric acid in it, and it should remove most of water from the gas mixture. I can then use this valve to control the input of my dry carbon dioxide into the gas exchange chamber. To lower the pressure, I have connected the chamber to my vacuum pump. By controlling how much carbon dioxide I add and how strong of a vacuum I pull, I can then control the color and brightness of my discharge chamber. Okay, I've just done an off-camera test, and it seems that the electrodes are getting much hotter than I expected, so I'm gonna have to remove the epoxy with some acetone and then proceed with the experiment. First, to make sure everything is working, I'm going to test some low pressure air. Now I'm going to generate some carbon dioxide. Now I'm going to pull a vacuum on the system. This mixture is part CO2, part air. Afterwards, I did several more flushes with carbon dioxide. However, I'm not almost certain that it did any significant changes to the color. Anyways, I hope you enjoyed, and see you next time.